Let's explore the world of file system implementation. File system implementation is a crucial aspect of operating systems, focusing on how data is stored, accessed, and managed on storage devices. We'll be covering the core storage management concepts, which includes allocation methods and free space management. This is essential for efficiently using disk space and ensuring data integrity. Now let's dive into the file allocation methods. File allocation methods refer to how files are stored on disk in terms of blocks. There are three primary methods: contiguous allocation, linked allocation, and indexed allocation. Contiguous allocation involves allocating a continuous block of memory. Linked allocation uses pointers to connect the blocks of a file. Indexed allocation uses an index block that contains the pointers to all the blocks occupied by a file. We will explore each of these methods in detail. Let us understand contiguous allocation in detail. In contiguous allocation, each file occupies a set of contiguous blocks on the disk. As you can see in the illustration, file A occupies blocks 1, 2, and 3, while file B occupies blocks 6 and 7. This method offers fast sequential access and simple file addressing, which helps to quickly locate and retrieve data. However, it suffers from external fragmentation, where available memory becomes fragmented, and the file size must be known at the time of allocation. The size has to be pre-declared. Also, as the files grow, they might not be able to find enough contiguous space. Now let's discuss linked allocation. In linked allocation, each file is a linked list of disk blocks, which need not be contiguous. Each block contains a pointer to the next block. The directory entry contains a pointer to the first block of the file. As you can see, file A starts at block 5, which points to block 12, and block 12 points to block 8, and finally block 8 contains a null pointer signifying the end of the file. This method eliminates external fragmentation and allows dynamic file growth, meaning files can expand easily as needed. However, it has slow random access because to reach the block 8 we have to traverse starting from block 5. Also, there is a pointer overhead for each block, reducing the storage space available for the actual data. Let's explore indexed allocation. Indexed allocation solves the problems of contiguous and linked allocation by bringing all the pointers together into one location, an index block. Each file has its index block, which contains pointers to all its disk blocks. The directory entry contains the address of the index block. The index block contains many pointers, enabling it to translate to large file sizes. As shown, the index block contains entries such as 0 pointing to block 4, 1 pointing to block 7, 2 pointing to block 12, and 3 pointing to block 15. This provides direct access to blocks and avoids external fragmentation. The downside is the overhead of the index block itself and potential limitations on file size, depending on the size of the index block. Let's move on to free space management. Free space management is the way the operating system keeps track of which blocks are free and available for allocation. There are several methods to achieve this: bit vector or bitmap, linked list, grouping, and counting. The bit vector uses a binary representation of block status, and the linked list uses a chain of free block pointers. Grouping stores addresses in free blocks, and counting tracks contiguous free blocks. Let's examine these methods in detail. Now let's delve into the bit vector method. In this method, a bit vector or bitmap is used, where each bit represents a disk block. If a bit is 0, the corresponding block is free, and if it is 1, the block is occupied. As illustrated, you can see the bit vector representing the status of blocks 0 through 11. The code snippet shows how to find the first free block, mark a block as occupied, and free a block using this method. This approach is simple and efficient for finding contiguous free blocks, but it may require significant memory for large disks. Now let's explore the free space linked list. In this method, the free disk blocks are linked together, forming a linked list. A head pointer points to the first free block. Each free block contains a pointer to the next free block. As depicted, the free list head points to block 3, which points to block 7, and block 7 points to block 12, and finally block 12 contains a null pointer signifying the end of the list. This method doesn't need any extra space as it uses the space in the blocks themselves. It offers fast allocation and deallocation of free blocks. However, it can't easily find incontiguous free blocks. Also, it's prone to corruption if a pointer is lost or damaged. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.